I appreciate that kind introduction. My first slide takes you to an evening in South Florida where the sky is clear. That's you in that picture, looking up in the sky. When you look up in the sky, what do you see? Stars, maybe a planet or two, gas, dust, galaxies. The point is, you see something rather than nothing. We're going to talk about why it is that you see something rather than nothing. And it all comes down to the ripple effect in space and time. So this is going to be the takeaway from my talk, this picture. This is called the cosmic microwave background radiation. I'm going to explain why it's called that, but it's the takeaway from my talk. If you remember nothing else, I'm going to show you this slide 3 times. So it will come back to haunt you, if you will, throughout the talk. But what do you see in this picture? Well, you see an oval. You see splotches of red and blue, and they vary in different parts of this picture. I'm going to explain to you why this picture looks the way it does, and how it explains there is something rather than nothing. But first, I want to give you a sense of where our place is in space. We are on the Earth. The Earth is a planet in the solar system. The solar system is the sun, 8 total planets, of which the Earth is one. The solar system and the sun is one of 100 billion stars in the Milky Way galaxy. We're about 2/3 of the way out from the center of the galaxy. The Milky Way galaxy is one of about a couple of dozen galaxies in the local group of galaxies. And the local group is part local supercluster, and that is in the universe. So this slide puts the scale of our position, our location in space on your mind. And the next slide will do the same for time. This is our place in time. On the right, you have the present. On the left, you have the past. The universe is 13.8 billion years old. On the left is the Big Bang, the beginning of the universe. And then somewhere soon after that is the cosmic microwave background. And then the first stars formed, and the first galaxies, planets, and then to today, which is where we sit. This is our place in time. From the beginning to today, 13.8 billion years of time. Now, coming back to the cosmic microwave background, why is it called that? Cosmic microwave background radiation. Why is it called that? Cosmic refers to the fact that this radiation, by the way, radiation just means light. It's cosmic. It comes from above the Earth. It comes from space. It's in the microwave. That just means that it's a kind of light that your eye cannot see. It's radio waves. Your eye cannot see it. It's in the background, which means it's everywhere. No matter what direction you look, you will see this if your eyes could see microwave light. So it's the cosmic microwave background. Radiation just means light. That's why it's called that. Sometimes you'll see it referred to as the CMBR for short. The point is that all those colors represent different temperatures. The red is a little warmer than the average, the blue is a little cooler than the average, but the point is, it is not smooth. It is not smooth. It's lumpy. That's a technical term, by the way. It's lumpy. There's variations in temperature, which refer to density in the sky. And this represents the first image we have of the universe after the Big Bang. The Big Bang, and then the CMBR, and then everything that happened after that is what you see in the sky. The stars, planets, gas, dust, everything else. And so the next one, I want to talk now about how is it that the microwave background actually produced galaxies. Well, this slide shows you a computer simulation of the early density fluctuations that led to the formation of galaxies. Whenever you have small density fluctuations, what naturally happens is gravity takes over. Gravity causes these fluctuations to collapse and form stars and galaxies and clusters of galaxies and all the things I showed you in one of my earlier slides. And what this slide shows is a computer simulation of the density fluctuations of the early universe allowed to propagate through the ripple effect over time. And what did they do? They made galaxies. What do the galaxies contain? Stars. What do some stars have around them? Planets. That is how our planet, star, galaxy came to be. Now, the next question is, all of these planets and stars we're making, what are they made of? So this is a table of the elements, and I'm sure you've seen this in your classrooms. I'm sure you've all seen this in your chemistry or physics classroom. And what it shows is the chemical elements that we are familiar with on the Earth. At the top, on the left, you have hydrogen. On the right, you have helium. Those are the most abundant elements in the universe. Below, you have everything else. Things like carbon, nitrogen, oxygen, aluminum, magnesium, uranium, all those elements. Where did those come from? Well, hydrogen and helium were produced in the Big Bang. Everything else was produced in stars. So if you look around you, look at your friends next to you, look at this building where you're sitting, your chair, all the atoms around you were once inside a star. That's where they were made. So not only did the cosmic microwave background produce density fluctuations that then produced stars, but those stars then made all the stuff that we're made of in this room. Without the cosmic microwave background, none of this stuff, if you will, would exist. And in astronomy, most astronomers refer to everything heavier than helium as metals. So hydrogen, helium, and metals. So the next slide will show you what I'm talking about with respect to the evolution of metals over time. This is a graphic that shows the Big Bang on the left, and then today on the right. At the Big Bang, there was just hydrogen and helium, nothing else, zero metals. And over time, as stars formed, they synthesized heavy elements inside them. Those were then used to make more stars, more stars, more stars, galaxies over time. And of course, many of those stars had planets going around them, and that's how it is that we came to be. So at the beginning, hydrogen and helium. Today, hydrogen, helium, and all the other chemical elements we have in the periodic table. And this is, again, my takeaway, the cosmic microwave background. This is the reason why we exist. I should rephrase that. This is how we exist. Why we exist is a philosophical question. This is how we came to exist. That's my last slide, and I appreciate your time.